Hi, and welcome to another video on the theme of not all SQL is equal. So today I want to talk about something that's been troubling me for a while now. I'm not sure how other companies do things, but when interviewing to join our data engineering team here at PG, we ask candidates to answer a few simple questions on our Snowflake partner account while sharing the screen with us. Now, to be honest, I'm not actually interested as to whether they get the correct answer or whether they can remember the exact syntax for some obscure function. What I'm more interested in is how they approach the problem in the first instance and what their thought process is. Now, to my surprise, there's one particular question that seems to trip up a disproportionate number of people. When we talk through the question, it's obvious that they understand what they're trying to achieve, but when we finally get to the answer, I hear statements like, "Oh, we've been taught that that is wrong to use," or "If we see that in our query plan, we know we've made a mistake." In this video, I'm going to show you a version of that interview question and demonstrate that what you've been told about Cartesian joins is all wrong. My name is Malcolm Green, and I'm a senior data engineer, data architect at Projective Group, a boutique consultancy specializing in all things data. I've been working with databases for over 25 years, covering Oracle, SQL Server, Netezza, and now Snowflake. So, now to the question. So on our database, I have three tables. I have an authors table that contains 129 authors. Obviously, we have an author ID, which is the primary key, and the author name. I have a genres table. And again, I have a genre ID, which is the primary key, and I have a number of different genres, and I've got 12 records in total for there. And then I have another table that is the book table containing published books. Now we've obviously got a book ID, which is the primary key, a book name, which obviously is just gobbledygook in this case, and then two foreign keys, one to the author of the book and one to the genre of the book. And I have 7,519 published books. So a requirement comes in that says, I wish to identify the total number of books that each author has published in each category. If an author hasn't published a book in a category, then the number 0 should be displayed. And as a hint, the total number of records in the final data set should be 1,548. So if we were to say, what should the data set look like? Effectively, we want author name, genre name, and the published count. And what you can see here is Peter Ackroyd has published 0 books in the science genre, and Amir Axel has published 0 books in the comic genre. So the interviewee is sharing their screen and they're having a go at answering this question. And we see left joins, and we see right joins, and we see unions, and it's quite obvious they're going through all the different combinations and they're struggling. So at this point, I tend to intervene and say, "Come, talk to me. Tell me what you're trying to achieve." So they say, well, what we're really trying to do is get every combination of author and genre and then use that to join to the table that's got the list of published books, and then we can see how many they've published. So I say, great. And then they go back to it, and we're now still looking at left joins, right joins, and unions. So I intervene again and say, can you talk me through the joins that are available? So we get an explanation of inner joins, we get an explanation of left outers, right outers, and then finally we say, oh, there's also this thing called a Cartesian product or a cross join. But we've always been told, I've never used that in my life as a data engineer, and it's every time I've seen that, it's because we've made a mistake. And that's frustrating because the Cartesian join is a join that is available in our toolkit, and there are scenarios where the Cartesian join should be used. And in fact, this is one of those scenarios. If you ever find yourself saying, and I need all combinations of, that is usually a hint that you need a Cartesian join. So if we actually go and look at the answer, sorry, what you'll see here is I select from author and I do a cross join to genre. That will get me every single combination of author and genre that is possible. Because obviously with a cross join, you do not specify an on condition. Once I have that Cartesian product, then I can left join to the book dimension on author ID and genre ID. And obviously, I'm picking the author ID from the authors table and the genre ID from the genre table. Obviously, the result of the cross join. And then in my main query, I can do a select a count of the book IDs. So if I was to run that query now, what you'll see is a total of 1,548 records in my data set, which, as we discussed before, is exactly the number that we're expecting. And if I then go down here, you will see there is Peter Ackroyd and science genre, 0 records. And let's just go down a little bit further. And here is Amir Axel with the comic genre has also generated, published 0 records. And if I just very quickly change this just to have the sum and the count, what you'll also see here, this is just a check really, the total number of books to published, which is my sum of my published count is 7519, which ties up exactly with the number of records in my book dimension. So I've got all of those, and the 1548 showing the number of records in my data set. So hopefully in this short video, I've shown you that, Cartesian products, cross joins are in your toolkit. They are valid constructs that you should be using, obviously in the right scenario, but please don't rule them out just because you've always been told they're wrong. They're not always wrong. They're correct in the right scenario. I hope you found this useful. Please, any comments below, and please subscribe to hear about future videos in this series. Thanks again. Bye for now.